Intermolecular forces, summary and wrap up. Here we're just going to do a very quick summary of the intermolecular forces that we've discussed. We'll identify the intermolecular forces present in a few molecules and discuss the alternative names for IMFs. And we'll talk about another example of these in living species, specifically the gecko. In intermolecular forces, we have our four types that we discussed: our London dispersion forces, our dipole-dipole forces, our hydrogen bonding, and our ion dipole. I mentioned throughout the other videos that some of these are weaker than others, but now let's talk about this specifically. In general, our London dispersion forces are our weakest, with our dipole-dipole following, hydrogen bonding being next, and then our strongest of the four forces is ion dipole. These are all in general. There is a theoretical possibility for atoms that London dispersion forces of a very, very large atom could overwhelm a very weak dipole. And this is something that you should be able to explain if given an example of something with a dipole that yet has weaker intermolecular forces. However, it's not something that you would be expected to predict in this class. So for us, unless I show you an example and tell you the answer and ask you to explain it, you can use this weak to strong gradient to rank the intermolecular force strength, which will later on result in ranking the boiling and melting temperatures. Let's do an example where I ask you about all of the intermolecular forces. So here I've asked you about Ci4. Ci4. Take a minute and try to do this yourself. Draw the molecule and decide which intermolecular forces are present. To know this, we must first draw the molecule. Here I've put the C in the center, the four I's surrounding it. If you're having trouble drawing the Lewis structures, please make sure to go review the videos on this. Since we know that all molecules have LDFs, we can say that this molecule has LDFs. To decide if it has a dipole-dipole force, we need to determine if there is a dipole, or if the molecule is polar. While each of these bonds are polar, a Ci bond is polar. Because they all point in exactly opposite directions, their vectors cancel, and there is no dipole. And therefore, there is also no dipole-dipole forces. Please be sure to review your videos on VSEPR and molecular polarity if you are having trouble with that section. Since there is no hydrogen bonded to an N, O, or an F, there is no hydrogen bonding in this molecule. So in summary, it has only London dispersion forces, nothing else. Let's do another example. Pause again and try to do this one on your own before moving on. So here I ask you what intermolecular forces are present in CH3Cl. To know this, we must first draw the molecule. The C goes in the middle, and the H's and the Cl go around the carbon. Since we know that all molecules have London dispersion forces, we can safely say that this has LDFs. To decide if it has dipole-dipole forces, we need to determine if there is a dipole. The CH bonds are not polar, but the Cl bond is. Since there is only the one polar bond and nothing to cancel it out with, it is a polar molecule, or in other words, it has a dipole. Since it is a polar molecule, that means that yes, there is dipole-dipole forces. Now what about hydrogen bonding? We do have hydrogens in this molecule. However, those hydrogens are not bonded to an N, an O, or an F, and so there is not any hydrogen bonding. Therefore, there is only London dispersion forces and dipole-dipole forces. Now let's go on to one biological example I just wanted to mention as we were summarizing our forces. This also gives me a chance to introduce another term that we use as an umbrella term for all of the intermolecular forces that we've talked about so far. Van der Waals forces is an all-encompassing term for LDFs, dipole-dipole, and hydrogen bonds. This is actually what holds geckos to the wall. The exact mechanisms aren't even known, but it appears to be a complex combination of all the van der Waals forces. This is what allows geckos to be able to easily pull their foot off the wall, and yet when they put it back on the wall, have it stick.